Okay, welcome again for those that have joined. I guess I'm just going to give it a few more seconds, but it seems like those that are going to join have joined. Rolene, you can hear me. You're happy for me to start with the introduction? All right, cool. So welcome everyone. My name is Dr. Amy Allright from the Institute for Groundwater Studies at the University of the Free State. I am the central branch for the groundwater division. Yeah, this is our first event for the year. Rolene Lubbe, she'll introduce herself in a bit, it's her brainchild for this event. So yeah, I just welcome you all here. And I see we've got a good few of the groundwater division members that have joined. Danita, I see you. Hey. Gideon, welcome. And yeah, Fanus Fourie, welcome, the chair of the groundwater division. Thank you for joining us. It's very cool to see you online. Yeah, so the event today is to celebrate World Wetlands Day. And as groundwater specialists, I think we're all aware of wetlands, but often it's a bit of a question mark. I think it is a bit of a question mark in terms of how to deal with it, and who's responsible for what. And I think we all unfortunately work in our silos, where if you're a geohydrologist, you kind of look at everything through the lens of and if you're a hydrologist, you're looking at the same problem, but through a lens of, from a surface water perspective. So I think it's good that we start having these talks to start meeting somewhere, where these two resources meet, to start collaborating to better protect them and quantify and everything like that. Yeah. So welcome to everyone. I hope you enjoy the talk. And with that, will you please put in the chat box your name and affiliation? This talk has got CPD points, so that's just for us to take an attendance register. Just make sure that everyone gets their certificate. But with that, I will hand over to Rolene, and she'll introduce the speaker. Thank you all very much. See you then.
Hi, everyone. I would like to introduce myself, Rolene Lubbe. So I am the representative for the Groundwater Division, the Young Professionals of the Central Branch, which is situated in Bloemfontein. I am a full-time PhD student and research assistant at the Institute of Groundwater Studies at the University of Free State. And I will be introducing the speaker for today, which is Steven Ellery. He is a wetland ecologist, and he will be presenting World Wetlands Day, for the World Wetlands Day presentation, Wetlands, a Friendly Introduction. So I just want to provide a short introduction on him himself. Just want to share my screen here, just the program. So Steven Ellery is a wetland scientist at a specialist environmental consulting firm called GroundTruth in KwaZulu-Natal. He has grown up surrounded by wetlanders in wetlands, as his father is a well-known wetland researcher and educator in South Africa. And he has inherited his father's passion for muddy hands, swell augers, and star gumboots. He has 4 years of professional experience with GroundTruth as a wetland ecologist, wetland educator, and drone pilot. He has a master's degree in wetland geochemistry and geomorphology. And he is a registered professional natural scientist with the South African Council for Natural Scientific Professions, SACNASP. He also sits on the board of trustees at the South African Wetland Society and belongs to the Society of Wetland Scientists, which is an international wetland organization. And with that, I would like to formally hand over to Steven. Thank you.
Great. Thank you so much for that introduction, and it is really good to be here. Yeah, just looking at some of the names on the participants lists, I recognize some of you, which is really great. So good to be here. And yeah, I'm really, as Rolene has alluded to, I'm really passionate about wetlands, and it's something that I hope to dedicate the rest of my life to. And I really hope that with this not too scary, somewhat friendly introduction, maybe I can entice some of you guys into bringing your expertise in groundwater and hydrogeology and hydrology into the wetland space, because as you will hear, it is sorely needed. I just want to check, can everyone see my shared screen and presentation?
Yes, we can see your screen.
Great. Cool. So without without further ado, you know, I'm going to go through this and maybe quickly, if there are any at any stage, please do feel free to put up your hand or interrupt me to ask a question. I like lecturing, but I also like to discuss things. So just want to say that, and I might breeze through things that I assume, I assume you guys know, but if I'm going too fast, please just do let me know. So as you can see from these 4 pictures, wetlands come in many different shapes and sizes, and they occur in many different landscapes and locations. So, you know, you can get a forested wetland, you can get a completely grassed wetland, you can get an enormous wetland that covers many square kilometers, and you can get really, really small little wetlands that are, you know, only receive water from precipitation and rainfall. So, you know, they are one of the most diverse ecosystems in the world, and, you know, they occur all over the world. So it really is quite a diverse and interesting field of practice and field of study. So in South Africa, we define a wetland as land which is transitional between terrestrial and aquatic systems, where the water table is usually at or near the surface, or the land is periodically covered in shallow water, and which land in normal circumstances supports or would support vegetation, typically adapted to life in saturated soil. So I've highlighted these parts of this definition, and we're going to just take a little bit of a deeper dive into what these actually look like and what they mean and how they interact. So you can see I've colored the definition according to this little conceptual model that I have here. So first, we're going to look at geomorphology, and that really speaks to land and landforms. And we're going to take a deep dive into each of these aspects of the fundamental drivers of wetland origin and wetland formation. So geomorphology refers to land and landforms. Hydrology, I'm sure most of you know, refers to water, either surface or groundwater, as well as the water table. And vegetation refers to, in a wetland context, hydrophytic vegetation, or vegetation that is adapted to living in saturated soils. And then around these 3 components, you will see that there is climate and there is geology, both of which play, to a lesser degree, but an important role in the formation of wetlands. So what is geomorphology? According to the Oxford Dictionary, it's the study of physical features on the surface of the earth and their relation to its geological structures. Or another definition that maybe I prefer is, it's the study of landforms and the shape of the earth's surface. So really, in other words, it attempts to explain why landscapes appear the way they do, and how they affect current landscape dynamics. And I'm sure, you know, if we imagine a valley, for example, it is the, you know, the bottom of the valley is the low point in which water typically collects, and that valley bottom would be considered a geomorphological structure. So, you know, I'm just going to take a little bit of time to go through this. So this hill slope is a geomorphological structure, and when water falls on top of the hill, it will naturally, because of gravity, run down the hill slope. Now, what if you introduce a geomorphic, resistant geomorphic feature, which we as wetland scientists call a base level, which is resistant to erosion and therefore may slow the water down, and it may act as a base level, or a nick point, as we also call it, to create conditions that are conducive to wetland formation. And this is something that happens all the time, and we'll talk about this a little bit later. But also on the right-hand side here, you can see a valley bottom. And as a geomorphic feature, that is typically where water collects So, and those geomorphic features often result or are formed as a consequence of geology, lithology, as well as hydrological movement over those land surfaces. So, yeah, some new terms, maybe not new to all of you, but erosion is the movement of soil or sediment or land from one place to a place where, you know, it is deposited and where deposition takes place. And through that process of erosion and deposition, wetlands often are found. And we'll talk about this in an example a little bit later. But in South Africa, typically, wetlands form because there is a local base level that is preventing erosion and is slowing down the flow of water enough to create wetland conditions. So in a sense, geomorphology as a whole and the geomorphological landscape in South Africa is can be thought of as the template upon which surface hydrology, wetlands, is created. So, what is hydrology? Well, according to the Oxford Dictionary, hydrology is the study of properties, which are the movement, distribution, and quality of the Earth's water in relation to its land. So you can see already that there's a link between hydrology and land surfaces. So hydrology attempts to explain the physical properties of water and how it interacts with landscapes. And you know, I'm sure we're all aware of some of the flooding that's happened in KwaZulu-Natal last year and this year, well, last year mostly. And we also, you know, I'm sure that just speaks to the power that hydrological processes can have if they aren't managed properly or well. And, you know, those hydrological events, those floods, are often a consequence or, you know, partially a consequence of changes in the landscape and the geomorphology of the surrounding landscape and the catchments of those systems. So here we'll talk a little bit about how groundwater and surface water interact to form wetlands. So wetlands, as we see in the definition, are aquatic systems where the water table is usually at or near the surface. And we'll talk about this, but we define wetlands as when there's water within the top 50 centimeters of the soil surface. Anything below 50 centimeters, typically wetland plant roots can't reach that, and therefore you actually get a movement away of hydrophytic vegetation when the water table is below 50 centimeters below the surface. So as I'm sure you all know, the water table fluctuates depending on various factors such as rainfall conditions, lithological features, fractured geologies, etc. So wetlands form in areas where the water table is above or near the ground level, and generally speaking, the interaction between wetlands and groundwater is poorly understood in the South African context, especially, as it has not been a focus of many research questions in the past. However, there has been a recent focus and a recent uprise in the understanding of this interaction. And there have been many more studies that are being done to unpack the interaction between wetlands and surface water. So, you know, this is a subtle call, or not so subtle call, to you guys as hydrologists and groundwater specialists to consider, you know, asking more questions about, well, how do groundwater features contribute to wetlands, and how do wetlands contribute to groundwater features? You know, but it is generally understood that many wetlands are supported by local groundwater recharge through interflow and through the presence of local perched aquifers. And I'm sure a lot of you know that certain geologies have strong groundwater linkages. You know, in geologies where there are a high occurrence of fractured or fractures within geology. And it is often assumed that wetlands found in those areas are at least supplemented by groundwater. But again, this is not always certain, and there's a lot of research to do in that space. But a well-known example of a wetland complex, and we were chatting about this wetland complex just before the course started, is the Isimangaliso wetland complex, or the, towards Lake St. Lucia. And that wetland complex falls on the coastal plain, where there is a very strong ground surface water interaction. Further to that, many wetlands are known to recharge local and regional aquifers, and can often contribute to the hydrological inputs of groundwater systems. A great example of this would be the Crom wetland in the Eastern Cape, which is known for its prolific contribution to the local and regional aquifers there. So, to move on, as I mentioned before, typically we define wetlands as areas where the top 50 centimeters of the ground is saturated for enough time for the soils to produce what are known as hydromorphic soil features or hydric soils. And these features include, but are not limited to, glade soils, so basically where all the color drains out of the soil. And that also results in the formation of what are known as mottles, basically small iron or manganese reductions within the soils, and that is a result generally of a fluctuating water table. So as the water table rises towards the surface, iron and magnesium and manganese go into solution. And as that water table drops, and as oxygen is reintroduced to the soil profile, those elements are precipitated out of solution, and they create these small nodules called mottles. And then another feature that we use to identify wetlands is, of course, vegetation that is adapted to saturated conditions, aka hydrophytes. So a hydrophyte is a plant that is adapted to living in either waterlogged soils or completely submerged soils. So in many ways, the presence of hydrophytes in the landscape is a result of the interaction between hydrologic and geomorphic features. Hydrophytes are often used as effective monitoring tools to detect and assess changes in hydrologic and geomorphic features in the landscape. And they can show change in a matter of months. So, if all of a sudden a dam is built on a wetland or upstream of a wetland, for example, the drying up or the holding back of that water will be reflected fairly rapidly in the vegetation signatures in that wetland. So many wetland vegetation indices or indicators have been created as a surrogate measure of wetland water quality as well as wetness regimes within a wetland. Just to say, I'm not monitoring the chat at all. So if there are questions coming in the chat, please let me know. So to come back to this conceptual diagram, we can see that there are dark arrows and dashed arrows. So a dark arrow in this conceptual diagram represents a very strong influence. So we can see that geomorphology has a very strong influence on how water moves across and through a landscape, and hydrology has a weaker influence on geomorphology. And hydrology and geomorphology both have a very strong influence on vegetation and the type and the composition of vegetation found within a wetland, and vegetation has a weaker feedback on hydrology and geomorphology. And just to note something that took me a while to get used to, but really helped in my understanding of these three drivers, is that typically when we consider geomorphology as a science or as a discipline, we talk about a time scale or a temporal scale that is just much greater than hydrology or vegetation. So, we talk about millions and millions of years of the evolution of the landscape being shaped by different processes, sometimes tectonic processes, large uprise events in the case of South Africa. And when we talk about on a hydrological scale, that time scale that we generally consider is much shorter. So that's why I always like to use geomorphology as kind of this base template upon which we can then start building our understanding of a wetland, and then adding the hydrology on top of that, and then adding the vegetation on top of that. And then after that, human impacts like water quality issues and things, which we will talk about just now as well. So what does this all look like, actually? Some general rules. Wetlands form on gentle slopes, often, where water flow is slow, and often as a result of dense vegetation cover. Wetlands often form in areas where there are both erosive and resistant geologies. So the resistant geology forming a base level and allowing for the erosion upstream of that resistant geology to form flat and gently sloping conditions in which wetland formation occur. And wetlands often form in areas where there's sufficient annual rainfall, which is as part of that conceptual model of the climate aspect, to sustain long periods of saturation. Wetlands also come in many different shapes and sizes, and it should start becoming clear to you that geomorphology and hydrology are the main drivers of wetland formation. And this has resulted in a classification system of wetlands according to what we call their hydrogeomorphic type. And so the hydrogeomorphic type, or HGM unit classification as we call it, utilizes a system that is based on the geomorphic position of that wetland, as well as the hydrologic characteristics of those group of wetlands. So the widely used HGM, if we take this example again of a resistant rock layer or base level at the toe of a slope, and with water flowing over that hill slope, if the discharge of that water is too great for the slope, it will result in erosive conditions, and basically the cutting out of that hill slope until the discharge from the catchment is appropriate for the slope of the wetland. And once this process has occurred, you will see that there's a much more gentle slope upstream of that resistant rock layer or base layer. And that's a very typical way that an unchanneled valley bottom wetland forms in the landscape. And again, when we're thinking of this geomorphic process, this can happen over hundreds of thousands of years. And if we think about how quickly we can, put a drain into an unchanneled valley bottom in a matter of days, we completely undo those hundreds of thousands of years of work that has happened to create that unchanneled valley bottom. So also just a call to us to really consider our impact on the environment. Of course, I feel like I'm speaking to the converted here, but yeah. So the conceptual model generally, or just more the inflows, outflows, and flows, you can see that typically, there is a channeled inflow into an unchanneled valley bottom. Once it hits that unchanneled valley bottom, the through flow is typically characterized by diffuse flow, which is often in the direction of the slope of the wetland. Generally, unchanneled valley bottom wetlands receive interflow from lateral inputs, so from the valley side, as well as overland flow from surface hydrology coming into the wetland. And also typically they are characterized by infiltration, so they can often act as groundwater recharge points, sometimes groundwater inflow. So one of my favorite wetlands in the whole world is the Umgeni Vlei here in KwaZulu-Natal, and it is one of the most spectacular examples of an unchanneled valley bottom. And you can see here that there's a channeled flow coming in, and as it hits this massive, very, very flat valley bottom, it just spreads out into this really incredible wetland. So yeah, if you ever have a chance to go to the Umgeni Vlei Nature Reserve, I really encourage you to go and have a look. It's spectacular, and there are just many wattled cranes and blue cranes and all sorts of beautiful bird species out there. So it's really special. And then to introduce a second type of wetland, seep wetlands. So typically seep wetlands are found on slightly steeper gradients, and they are often driven by the movement of water downslope, and they can be characterized by gentle to very steep slopes. They are associated with geomorphic formations quite often that cause groundwater to surface. So often they're associated with a resistant lithology or a perched aquifer that forces groundwater out onto the surface, creating a seepage wetland. So just a quick example of a conceptual model of a seep wetland. They are often contributed to by overland flow, but typically most of the flow that enters or surfaces in a seep wetland is through interflow, and then often there's groundwater contributions as well. And here's an example of a seepage wetland with a small spring at the head. And again, you can see just by these contour lines that the gradient is fairly steep, but there are hydrological conditions, i.e. groundwater contributions, which are allowing for this wetland to persist in the landscape. So what do we know so far? Wetlands are a unique meeting point of aquatic and terrestrial systems, and they form when specific conditions work together, or features work together to form ideal conditions for wetland formation. And we spoke about two of the HGM unit types as defined by Dean Ollis, and they are often characterized by slow-flowing surface and groundwater, fluctuating water tables, hydric soils, hydrophytic vegetation, and diverse habitats for biota, plants and animals. Now, some of you might be thinking, well, so what? Why should I care about that? It's just water and land and plants. Well, wetlands provide us with trillions of dollars of ecosystem services completely free of charge. We don't have to pay for any of it. And so it's no wonder that ancient civilizations, such as the Egyptians, such as some of the great Middle Eastern civilizations, expanded or started and formed themselves and expanded from areas where wetlands were plentiful. And so I mentioned ecosystem services. What are ecosystem services? The definition that I really like is the aspects of ecosystems that are utilized actively or passively to produce human well-being. And when we consider ecosystem services, we typically think of four broad types of ecosystem services, namely regulating, supporting, provisioning, and cultural or non-material services. So very briefly, what are regulating and supporting services? These are services that are provided by wetlands that assist, for example, in flood attenuation. So, you know, one of the big discussions that has happened in the eThekwini or the Durban municipality recently is how we can revive wetlands within the municipal land holdings to provide flood attenuation, to prevent further floods like the ones we had last year. And that is a function of wetlands having generally gentle gradients, as well as quite robust vegetation that slows the flow of water down drastically. You know, and also if those stream flows or groundwater inflows into wetlands are polluted for whatever reason, the nature of the interactions between the plants and the soils in wetlands are, you know, really great at breaking down contaminants. And, you know, often wetlands are referred to as sponges or the kidneys of the world or great filters. And this is wise because they are really phenomenal at processing and assimilating contaminants. They also provide very slow release of water. You know, they're often referred to as sponges, so they release water very slowly. And so especially in dry periods, wetlands often remain wet for much longer and can provide stream flow regulation to downstream areas and, you know, provide at least a consistent flow of water for human use, as well as they provide critical wildlife habitat for many unique and endemic species. Provisioning ecosystem services. So this is basically what we can harvest from them, what we can derive. So, you know, water, for example, is a big one. You know, lots of people cultivate in wetlands, rice paddies, and many madumbis are grown in wetlands as well. You know, there's also lots of fish and just food. They're abundant in terms of their fish or the food that is produced. And, you know, during dry periods, they also can provide phenomenal grazing resources for cows, cattle, sheep, goats. And then many reeds, many crafts can be made from wetlands. You know, they are abundant in reeds, and there's a particular species here in KZN, it's known as Ikwane or Cyprus latifolius, which is used to, you know, make beer baskets and mats and all sorts of things. So those are some of the provisioning ecosystem services. And then the cultural or non-material services that are provided. Yeah, and those include cultural and spiritual experiences, birding, tourism and recreation, and of course, education and research. I recognize quite a few people from in the chat. We run lots of wetland courses, and we've had a couple of these. I know Tapelo and Oki and Pumla have all come on wetland courses. So, you know, it's also a great opportunity to be out in nature and learn about what's happening. But of course, with yeah, our increasing population, our increasing need for land and space and agriculture, we are putting wetlands in trouble. So healthy wetlands can provide a wide range of ecosystem services. But as I'm sure we kind of know, as wetlands degrade, they become less effective at providing ecosystem services. And yeah, one of the key questions that I often address in my line of work is how do wetlands degrade and how can we measure wetland degradation? So let's conceptually think about what is wetland integrity? What do we refer to when we think about wetland integrity? So wetland integrity is a measure of wetland health and is often referred to as the present ecological state of the wetland. And this is the perceived deviation from a theoretical reference or natural condition. So basically, before humans had any impact on a specific wetland, and that can be impacts in the catchment, it can be impacts in the wetland. That is the what we call the reference state or the natural condition. So it's a measure of the deviation, or the measure that of how much humans have impacted the wetland, and how much that wetland now in its current state differs from a natural reference condition. So, how are our wetlands degraded? I'm sure you guys can tell me as well as I can tell you how wetlands are degraded. But if we think about the three components of wetland formation, hydrology, geomorphology, and vegetation, we can actually get quite a good sense of how wetlands can be degraded. So if we remove hydrological aspects from a wetland through massive gum plantations or eucalyptus plantations, through the constructions of dams, immediately we are preventing water from entering into those wetlands. So, the movement of water through wetlands is one of their fundamental functions. And if we remove that water, well, we, decrease their integrity and their present ecological state drastically. But also, once water enters into the wetland, one of a wetland's primary functions is to slow water down and to distribute water across a wide basin. But if there are massive drains that are dug or channels that are dug into the wetlands, well, the water is just going to flow into those channels or drains and flow straight through the wetland and out at a much more rapid pace than what naturally would occur. And, of course, also, I mentioned erosion, and with high levels of grazing, with urbanization, as water flows into wetlands at increased runoff velocities, that can often trigger erosion. And the formation of large gullies and dongas. And those features in a wetland act in a similar way as a channel or a drain. And those also result in the degradation of wetlands. And then, of course, alien plants and the encroachment of, I've got a picture of bugweed there, and bramble, all sorts of alien plants have a negative effect, not only on the vegetation, but also on the hydrology. Some plants, as I'm sure we will know, have a much more rapid ability to take up water. And then, of course, water quality issues as well. So how can we measure the present ecological state? As we mentioned, the functioning of wetlands are driven by hydrology, geomorphology, and vegetation. And as we explored, the biotic factors respond to the nature of the abiotic factors. So vegetation responds to hydrology and geomorphology. And another aspect that is considered, another abiotic aspect that is considered when talking about wetland health is water quality. So if we take all of this into consideration, we can measure quite accurately now how hydrology has deviated from its natural state, how geomorphology has deviated from its natural state, how water quality has deviated from its natural state, and how that is all affecting vegetation, and how the vegetation composition of a wetland has deviated from its natural state. And we combine all of those factors together to come out eventually with a present ecological state. So, in conclusion, I know it was quite rushed and I spoke quite fast, but you should now know something about how and why wetlands are formed, drivers of wetland formation, as well as something about the HGM types, how to classify a wetland and what ecosystem services are, as well as what ecosystem services wetlands provide to humans, as well as factors that contribute to wetland degradation. Yeah, and I guess just how vital it is that we protect and conserve and understand these systems, because they are completely priceless, to be honest, in our landscape. And we really, really need to be more active in our just consideration of them in our landscape. And so I thank you all for your interest in science and wetlands and understanding these systems. It really is heartening, and it really is encouraging to know that there are people out there who are interested and really care. So thank you very much for listening. If there are any questions, please feel free. And yeah, thanks for being here.
Great, thank you very much, Steven. Everything was very clear, and I really enjoyed the presentation. Cool. But please, if you have any questions or would like to chat to Steven, please feel free to put your mic on or type a question inside the chat. I see there is one question already. Jayson asked to Steven, in terms of size, what is the usual spatial scale for wetlands?
Good question, Jayson. But to be honest, these systems are so diverse in their nature. You can have a system that is really small. In the case of maybe a depression wetland, I did my whole master's thesis on a depression wetland that was maybe 300 square meters in total. But then, you know, the Umgeni Flay is probably 250 hectares big, at least. So it really depends on the HGM unit type. So typically, the seep wetlands, the wetland flats, and the depression wetlands are smaller, and then typically the valley bottom wetlands actually occur over a much broader scale.
Great, thanks, Steven. I think that answered that question very clearly. So. There is another question here from Libuseng. She first comments and says a very informative presentation, and then asks if you know if there are any laws that protect wetlands in the country, and if so, are they typically enforced?
Also, good question. Thank you. And yeah, there are actually, South Africa has great legislation regarding the protection of wetlands. And in the last maybe 5 or 6 years, I think people are slowly catching on just the importance of wetlands in South Africa. And so, yeah, more and more those laws are being enforced, and more, you know, just in the last 3 years, myself and my company have been called on to a lot of what we call compliance projects, where someone has done something wrong in a wetland and someone has reported them, and that person is actually made to rehabilitate that wetland in some way. And so there are actually more and more, encouragingly so, the enforcement of those laws. And those laws are in the National Environmental Management Act, so NEMA, as well as the National Water Act. And they are quite detailed and quite good. I hope
cool, it's very
that
interesting.
Question. Yeah.
Yeah, sorry, I was just jotting something down. It was very interesting to hear that you're having compliance work now, people being forced to remediate wetlands. That's awesome.
Yeah.
There's a few more questions. So Fanus Fourie Can classify arid or semi-arid, something like in the Peru, differently?
Yeah, so there's a whole kind of sub field of practice in wetland science, which is wetlands in semi-arid and arid areas. I did my master's thesis on a wetland in a semi-arid environment, and that wetland was only, was only wet for 2 or 3 months every year. But because it has been wet for 2 or 3 months every year for about, I think we estimated the age of the wetland to be about 1.3 million years old. Because it has happened for that long, the soils are indicative of a wetland. But you definitely get different soil indicators and different vegetation indicators in arid and semi-arid environments. And you don't necessarily classify them any differently, but you certainly treat them differently when you are assessing them, and you certainly treat them differently when you are rehabilitating them or restoring them.
Cool, that's interesting to know. I guess off the top of my head, I would wonder in those sort of environments if groundwater plays a more substantial role because it's not as much, surface runoff in terms of precipitation, but that's just a
often in those environments, actually, wetlands act as groundwater recharge points.
Okay, because the water table is so far down.
Yes, and they are often primarily precipitation driven, and they really don't have any. There's little groundwater upwelling. It's mostly recharge.
Interesting. I see we've got a few more questions. Yeah, Jayson also asked, since the water table can emerge above surface, can springs be considered seep wetlands as well?
Absolutely, and often seep wetlands, you will find springs at the head of them or at the uppermost point, and that's the point at which a seep wetland often starts is a spring, and yeah, so as I said, there's all these groundwater surface water interactions that are fairly poorly understood, and it would be really great for more work to be done in that space.
Jayson also asked in that question, he says, in wetlands, what is the minimum percentage of ecological flow that's required? And is this accounted usually when we wish to regulate groundwater pumping? Yeah, that's also something I wanted to ask, because I know you can't really have a borehole within a certain distance of the river. And I assume that there's a similar regulation with wetlands. Yeah.
It's a great question, Jayson. And in terms of a minimum percentage of ecological flow, again, I wish that I had a better answer for how that groundwater surface water interaction occurs. We've just been involved in a large ecological flow study for the Upper Orange basement, and we've been asking ourselves the same question. Well, how do you factor in, the regulation of groundwater pumping in specific areas where we don't actually know what the groundwater surface water interaction is like? So as part of the study, we've had a groundwater or a geohydrological survey done, and it was found that the aquifer is quite far below the wetland. So in that case, there wouldn't be as much a regulation on the groundwater pumping for the sake of the wetland, because it's not necessary, it's not reliant on the groundwater. But if that groundwater area falls into a strategic groundwater source area, then there would be regulations against pumping from a groundwater perspective. And again, I think it needs to be taken on a case-by-case basis, on a wetland-by-wetland basis. So, just to understand the groundwater surface water interactions, and then to be able to, to determine what ecological flows should be stipulated in those cases. Yeah, so not really an answer, I'm afraid, but more just alluding to the fact that we need more research done.
yeah, not one size fits all, right? Fanus asked, can you please provide us with some more information on the courses on wetlands that you give? When, where?
Absolutely. So we provide at the moment, we have 3 different courses. One's an introduction to wetlands, so quite similar to what we've covered this evening, but in quite a lot more detail. And then we do an assessment course as well, so where we kind of teach you how to really assess a wetland for its present ecological state, as well as its provision of ecosystem services. And then we also go into some of the legislation regarding wetland mitigation and management. And then we also do a wetland vegetation course, and that's kind of more niche for those who are wetland ecologists. If you send me an email, just steven@groundtruth.co.za, I can provide you with all of that information. And we run them online as well as in person. So there's a hybrid, so you can, yeah.
Cool. Steven, can I ask you to just jot down your email in the chat, just for anyone that wants to get it? Rolene, do you want me to read your question, or do you want to ask it?
I think I'll rather ask it, then it's going to go quicker. Okay, so we know that wetlands are very valuable in terms of fauna, which is protected by NEMA, which is the environmental legislation. Hence why we are celebrating World Wetlands Day.
Yes.
Do CBAs, your critical biodiversity areas and ecological support areas, have anything in relation to wetlands specifically?
So absolutely. We have a wetland specific vegetation type, and I'm sure you've heard of the freshwater ecosystem priority areas. There's a wetland version, there's a river version, a wetland version of that. And I'm sure if Pumla is still here, she'll be able to talk about the work that Sambi is doing on National Wetland Map 6. And so there's actually a massive map of all the wetlands in South Africa. Well, a lot of them anyway. And that layer takes into account the critical biodiversity types, so the CBAs. It takes into account the ecological support areas. And it then basically comes up with a threat status of each wetland type in its it's in its vegetation type, which is tied quite strongly to the CBAs and the ESAs. So there is and we have to include information about that in all wetland reports that we write. So we have to do our homework on each of these wetlands that we write about and report on.
Thanks, Steven. I see there's one last comment here from Puti. He's asking, can you elaborate on how to distinguish between channeled wetlands and floodplain wetlands? They both seem to be occurring on the outskirts of a tributary, and which one is more likely to be ecosystem dependent?
Okay, I understand the first part of the question fairly well. This is a good question. And it's something that it can be quite challenging to identify. And it's a pity that I didn't include the floodplain HGM unit type in my presentation, because, you know, the floodplains have very distinguishing features. Generally, they have much bigger catchment areas. That's a general rule. It's not always the case. But because they have generally a much bigger hydrological load coming in, they, the channel course inside a floodplain will often avulse and change. So then what you start seeing when the course of the channel changes in a floodplain, you start finding these abandoned channels and backwater depressions and oxbow lakes. And those features are really only found in floodplains. a channel valley bottom generally has quite a shallow channel in its natural form, and it doesn't have those distinguishing features like oxbow lakes and backwater depressions. Yeah, so it's hard to explain that without illustrating it and without showing it. But that's one of the biggest distinguishing factors. And then maybe if I understand the second part of your question, so they do both occur along a river channel. So, you know, they are characterized by a channel that flows through a wide basin. And so, you know, there are many geomorphic factors that lead to the formation of a wetland in those contexts. But one of the predominant factors is that it's a channel that enters into a flat and broad valley bottom. And with that, when there's floodwaters, that water is able to get out of the channel and into the kind of adjacent wetland. Yeah, I hope that answers your question. If I didn't answer it, maybe you can clarify what you want to ask.
Pumla responded, and she says, Pudi also says, thanks, Steven, he's happy. Pumla also says you explained the NWM just to add that it is constantly being updated and improved, as there are still many areas in South Africa where wetlands have not yet been mapped. Sure, a colossal task, as I'm sure you can imagine, but we're getting there. Awesome. Thanks for the comment, Pumla.
Thanks, Pumla.
Olgi says, fantastic talk. Thanks, Steven.
Thanks, Olgi.
Jayson also says, I hope more stakeholders can listen to these talks. Yeah, this will be posted on YouTube as well, so I'm sure during work hours you'll get a few more hits. Yeah, so for now I think we at our time already, so I will echo all the thanks, Steven. I'm grateful that Rolene found you and that you were willing to give the talk. I definitely learned something. I know, you know, wetlands is, you know, is influenced by groundwater, but it's not something we like specifically think about very often.
Yeah.
So I thank you for that. And then and we have your email, so if there are any more questions or people want to speak to you about consulting or attending some of the courses, I'm sure they can send you an email. And then Rolene, is there anything that you want to do? Thanks, Steven. Your 2 cents.
I just want to thank Steven on behalf of the Groundwater Division and the Young Professional Society as well. Thank you for your time, and thank you for clearing your schedule and the wonderful presentation that you presented. I feel that everyone now understands what wetlands are, or just have an introduction on it, and how important they actually are to groundwater, and seeing the gap that there is for groundwater wetland research. So yeah, celebrating World Wetlands Day. Thank you so much, Steven. We appreciate it.
Great. Thanks so much. Thank you for this opportunity, and yeah, enjoy the rest of your World Wetlands Day, everybody.
Awesome. If I can conclude with a short blurb about the IAH conference that's happening this year in Cape Town. It's the 17th to the 22nd of September. I think we could all do with an excuse to go to Cape Town. So I'm going to post the link in here for you guys to go check out the information. Abstracts, the call for abstracts is currently open. Ends now on the 1st of March. So if you're interested, go have a look there. And yeah, hopefully we see you guys there. Steven, you're more than welcome to come present on wetlands if you want. It's the International Association for Hydrogeologists.
Great. I may just see you guys there.
All right. Yolanda, thank you for hosting us. And yeah, just a big thank you from the Groundwater Division and all the members that attended. I appreciate it. And yeah, I wish you guys all the best and a lovely evening.
Great.
Cheers.
Thanks, everyone. Cheers.
Thanks, Steven. Bye.